Hi, welcome to my YouTube channel. Myself Ravindra Reddy, NB USN 24LCS 2746. I am studied in Sri Venkateswara College of Engineering, Computer Science and Engineering, third sem, class Chanakya, course title Data Structures and Applications, course code BCS 304. We are discussing about topic about structural database of reducing cost in materials design and complexity of multi-scale computations. computations. Introduction. If we look back in the history of mankind, we can find that the first tools used by humans were made from wood and stones. Later, people described that bronze is better materials for knife than stone, and stone age changed to the bronze and later to the iron age. Better materials results in better tools and better life. Today we have a large number of different materials in our tools, but scientists still aggressively search for novel materials with desired properties in order to make our life better. The present article result from interdisciplinary research involving computer science, material science and engineering, physics and statistics. Isolated system of two electromagnetically integrating practically exactly three particles helium atom and approximately is needed. Heavier atoms with more electrons are more difficult to describe. This article organized as follows in section 2b pro video motivation of for multi-scale methods are to predict materials properties. In section 3 we discuss computationally complexity of the multi-scale methods. In section A, multi-step method combining quantum machines with status with described speed and the total error analyzed in section 3.2. We discuss these slowest step calculations of structural data purpose, a way to reduce computational cost in global integration. Predicting thermodynamic properties by multiscale. In order to calculate thermodynamic properties of a given material, one can consider a statistical example of all possible states of this material and estimate probabilities of these states at a given temperature. If for each state of property Ps is known, then property P of the material at temperature T is given by thermodynamic average for a simple state with only limited number of particles per primitive cell energy and same properties can be obtained from the principal calculations. However, the total number of states usually very large various the first principles calculations are very slow. Complexity of multi-scale methods. Combining quantum machine and statistics. Modern multi-scale methods allow first principles production, categorization, and explanation of materials thermodynamic properties. The methods that we will consider combine first principles calculations with statistical methods by constructing an effective classical model imitation fitted to the first principles results and concepts. Three steps. First principles quantum machines calculation typically based on density functional theory provide energies and electronic properties and limited number of selected sample automatic agreement structures. Second, a classical model elimination is constructed by fitting effective inter-automatic interactions to known structural energies. Thermodynamics is predicted by statistical methods such as a Monte Carlo, a molecular dynamics using the model elimination from step to a typical error of accurate DFT calculations is J0001. In principle, it can be made smaller by using better sufficient averaging. The structural database. We have designed they implemented the structural database which is now available through the web interface. At the major goals of the database are eliminate unnecessary recollections of structural data and to allow data mining processing. Previously obtained valuable information is not lost. Global data integration means putting the data from all researchers together in one place. It allows us to compare data from different methods, places, and people, and thus to verify reliability of the data. More structural data for fitting dynamic predictions. A data flow in the multi-scale method. Second, using the structural database is shown schematically in figure. The principal and entry relational diagram for the structural database is presented in figure 2. This diagram shows major entities connected to the relations. The structural database is thoughtfully designed in such a way that it involves only many to one or zero arrow and many to one and only one relations between the attributes. For example, a structural can contain many at homes, but each atom belongs to one and only one structure. Author, who is responsible for it information is inserted in a strict order. For example, one must insert of reference or a comment before inserting structural data. Hence, each structure in the database is commented. It is easy to see this and other restrictions in the diagram in figure. The structural database was implemented using Oracle database under the Red Hat Enterprise operating system. The user-friendly web interface is implemented in the Java using JSP and JDBC technologies. Examples of possible applications. Two examples of important applications and potentials of the structural database. We will maintain search for the ground status construction of an hello past diagram and prediction of new service patterns produced by etching semiconductor ground state search. In order to find the ground states of a multi-point material halo, and one can plot in energies of the lowest energy structures, various composition, and draw a convex hull structures on the hull or the ground. Fast diagram, surface patterning. The structural database can help to predict not only thermodynamic properties of bulk materials. As example, we will consider technologically important surfaces attached with halogens. Energies of service patterns are light elegance surfaces are very already calculated from the first principles and corresponding nearest near neighbor elegant interactions for this elegance were determined by fitting the energies. Conclusion. We propose the structural database as a universal tool for global integration and preservation of structural information. The database is implemented and available for use through the web interfaces, and it provides powerful operations for data mining. We have demonstrated eliminating unnecessary recalculation of known data can greatly reduce the computational cost of multi-scale collections. We use of data mined structural information from the database may also help to avoid new searches for relaxed automatic positions involving calculation of atomic forces, thus reducing computational cost and complexity of first principles. Provided by the structural database, we have considered ground state search construction of a patch diagram and prediction of new surface defects. We conclude that structural database is a powerful tool for information integration and data mining that can greatly reduce computational complexity and cost materials design. Thank you for watching my video. Please like, share and subscribe.